Hello.
Hello.
It's been a bit of a break. We've had a couple weeks off, but we're back.
Here we are. Here we are, up and running again. What do we got? Three more before the end of the year, and then we're going to go into 2021. Can you believe it?
Season three, I think, is how we've already been referring to it. So we're glad that you're back with us. My name is Ann Merchant, and you are.
I'm Rick Lovard.
And we both work for the National Academy of Sciences. And so, because they sign our paychecks, we always feel like the most important thing that we can do is, at least for anybody who doesn't know now, I feel like we should have like a guest that comes on and does this for us, because I'm sure that by now some of you could probably do this on our behalf. But the National Academy of Sciences is a private, nonprofit institution in Washington, D.C. I was just prior to this giving a presentation at the Entomological Society of America. And even among science people, there's that moment where I have to still give that little bit of explanation, because there will be that moment where someone says to me, no, I know exactly what the Academy is, and we really appreciate that grant that we received from you. And then I know that you think I work for the National Science Foundation, because we are the great takers of money, not the great givers of money. So that explanation can never be given probably too often, because people think we're part of the federal government, which we are not. But it's been a busy time at the Academy, as you might imagine. It's been sort of a good week for us in some ways, because I think lots of good news about vaccines. I think everybody's been very excited to hear about that. And we've also been getting a lot of play and I've mentioned this a couple times, for our framework report for the distribution and priority for how vaccines will be distributed. So when that time comes, I think that it's important to remember that even if vaccines are ready for production and distribution in the early part of next year, the realistic timelines for when they would be available more broadly are not quite that fast for those of us who want to be able to go to the CVS and roll up our sleeve. So the Academy is instrumental in creating the timeline for something like that. It was also really exciting for a lot of us to look at some of those early pictures on the Biden website. For those of you who have tuned in to previous events, for example, Peggy Hamburg was up on a big screen, and President-elect Biden was talking to her. She was one of his early advisors. And on the 13-member panel that Biden has put together for his COVID task force, one of the co-chairs is a dual member of the National Academy of Sciences and the National Academy of Medicine. And on his panel, there are four other members of the National Academy of Medicine. I wanted to call them out. Ezekiel, so the co-chair, David Kessler, is the NAS-NAM member. We call those double threats. Ezekiel Emanuel, Atul Gawande, Mike Osterholm, and Eric Gooseby are all members of the National Academy of Medicine. So we're very proud that President-elect Biden has turned to members of the Academy, and almost everybody else on that committee has been on various committees at the Academy. So that's a pretty cool thing. And so a lot of the work that we do is really very focused right now on the pandemic, but that doesn't mean it's the only thing that we're doing. And so the work that this institution does is amplified by programs like the Science and Entertainment Exchange. And so, Rick, maybe there's somebody in the audience that could do your job, but for now, you're it.
That's right. So if you are so I'm Rick Lovard. I'm the director of the Science and Entertainment Exchange, a program of the National Academy of Sciences. If you are a writer, producer, studio executive, storyteller of any kind, really and honestly any format, you have a question about science, you can call us at 844-NEED-SCI, and I suspect Sachi is going to put that up in the Q&A thread for you guys. 844-NEED-SCI, and we will hopefully be able to connect you with a scientist for free, who can give you insights and information about the science of whatever the story you're trying to tell may be. We have done over 300 events like this, and over 3,200 consults where we've connected storytellers to scientists in the last 12 years. including films like Avengers Infinity War, Man of Steel, Black Panther, Captain Marvel, and more recently Songbird. If you are a STEM professional, you're tuning in for the first time and you're like, whoa, I didn't know this existed, please reach out. We're always looking for more STEM professionals to connect to storytellers. Quick thank you to Ameche, who is running the whole show from behind the scenes and making sure we don't glitch and, you know, all that. And also the team in DC, Courtney and Jeff, as well as Sachi Gerben in LA with me. I also need to thank our sponsors, Howard Hughes Medical Institute, who made this event possible. Also, Alfred P. Sloan Foundation, Walt Disney Company, Film Nation, Google, the Lyda Hill Foundation, Corteva, and individual donors like many of you. Thank you especially to our supporter of science level folks who have received hopefully one of these in the mail. If you haven't, please reach out because we owe you one. For those of you who have donated, you will have access to a special VIP after Q&A session. You should have gotten a link for that already. If you haven't, please mention it in the Q&A thread and we will make sure to give you that link. And so basically what you're about to see is a single talk, Jill Tarter, one speaker, and then there will be a moderated discussion, and I will be scanning for questions starting in like 3 seconds. So if you have a question for Jill, please put it down in the little Q&A box. We'll get to as many as we possibly can. I'm sorry if we don't get to your question. We will try to get to as many as humanly possible. And also, last thing, you should have filled out, or you should have received from us last week or so, a survey. We are using your responses to this survey to figure out what else you want to see and, you know, how we're going to do our events in 2021. So please, we're really looking very hard at those surveys. If you have 2 minutes, please fill out the survey. It would be really helpful. Thank you.
Yeah, and it really is 2 minutes because we purposely tried to keep it short and easy so that you would actually fill it out. We know there's that bait and switch moment where you say 2 minutes and then you go in and start to take it. It's like, yeah, this is 10 minutes, but it really isn't. It's really 2 minutes, we promise. And so I also think it's worth mentioning today that it's not technically our actual birthday of the Science and Entertainment Exchange, but tomorrow is our 12th birthday because on November 19th, 2008, we launched the Science and Entertainment Exchange in Los Angeles with a big kind of coming out party. And Rick, you actually attended as an invited guest.
That's right. I didn't even work for you then.
No.
Whatever I wanted to, it would have been fine. You weren't even.
So we turned 12 tomorrow, and I also want to point out, you know, I mentioned NSF at the top of this. We did apply for funding from the National Science Foundation, and we were told that it's a really great idea, but probably not sustainable. Take that, NSF. We are still here thanks to the funders that you've already mentioned, Rick, and we're still here celebrating our 12th birthday. So there's that. And I also wanted to say that, so it's not a birthday, but I received this in the mail from the Academy. And if you can read it, which you probably can't, it's 30 years of service. Should I even admit to that? But I have been with the Academy 30 years. I don't know where I'm going to put this. I don't know, but 30 years.
And you said 30 years of service. There was another word on there.
There is?
Yeah.
Oh, 30 years of distinguished service. Yeah, it's probably a typo, but you know. Signed by our presidents. And if I were in an office, I would put it up on my wall. So I don't know, you didn't you find some birthday gifts for the exchange?
So I just really quick wanted to let you know that in honor of the exchange's 12th birthday, I was trying to figure out what I could get for the exchange, what might be appropriate for a 12-year-old. So I Googled it because that's what you do if you don't have a 12-year-old at home. There's this shirt that says awesome since 2008. I think that would be great for the exchange. Also, this DIY build your own knife kit, which seems really appropriate for a child, right here by Scrimshaw. And last but not least, certainly this useless box that you flick the switch and a little finger comes out and turns the switch you just flicked off.
I think that the exchange probably deserves all of those gifts. So wrap them up, send them out. But the gift that we have for you today in honor of the exchange's birthday is Jill Tarter, who is an amazing speaker. And I felt like we were especially prescient because we were sending out the survey, and one of the questions, spoiler alert, was what are some of the topics that you want to hear about? And really kind of at the top of the list was astronomy and cosmology. And so lo and behold, we had already issued our email to Jill asking her to join us on our virtual stage, because I think that, it is one of those very human things that we do. We look up and we wonder and we think about what's up there. And I think there have been a lot of answers that science has provided as we look up. Some of those answers have been provided by the technology that we've sent up into space. Some of those answers are theoretical. We also, at the academies, we have a board on physics and astronomy. We have the Space Studies Board. I actually looked, we have a report called, I don't know if Jill, if you have ever seen this report, it's called Signs of Life, a report based on a workshop on life detection techniques from the Committee on the Origins and Evolution of Life, which does not sound very sexy or very interesting, but it sounds very academy-like. And I think that there's this fascination culturally and curiosity scientifically. And I don't think there's anyone who more succinctly represents the way in which we have thought about this scientifically than Jill, her career and how she's inspired. I mean, listen, the character of Ellie Arroway, written by Carl Sagan and then given to us in the movie Contact, was inspired by Jill. So we are very happy. We've had Jill on our stage before. We're extremely happy to have her back. And so Rick and I are going to go away and we're just going to give the time to Jill, because that's, as I say, our birthday gift to you all.
Well, happy birthday, Rick and Ann. Really great. Let me start by finding my cursor so I can share my screen. Oh. Okay, did that work?
It did work.
Good, good, good. So I thought, well, first of all, for those of you that watched the intro slides before the actual presentation began, this is not going to be a talk about Area 51 or UFOs over the Capitol. And I thought I would take it in a slightly different direction beyond the standard, here's the science, here's what we do, to kind of personalize it and make it more human involved discussion. So I thought I would start with that title and then introduce myself. Oh, goodness gracious. Okay, something has frozen up here.
Jill, are you having trouble getting the slide to advance?
Yes, I am.
So so sometimes that happens. Maybe if you just, if you click on the slide.
Yeah, okay, that's
There
what
you
I was
go.
trying to do.
Yeah.
So my own way of introducing myself is that I've spent my career with a team that uses radio telescopes to try and find evidence of someone else's technology. So I have degrees in engineering physics and astrophysics. I've only really ever had one job, and that's dealing with SETI in various forms. So when NASA was doing SETI, I was the project scientist. I was the first employee at the SETI Institute, which I co-founded in 1984, and then have taken on various titles and projects, including the only foray outside of the SETI Institute was to be president of the California Academy of Sciences for a few years. I just got an honorary degree from the University of Pennsylvania, and I'm retired, but still cheerleading for all things SETI. And as I said earlier, I'm the one that's not wearing the headphones in this image. So I think before we start talking about finding them and how we might do that, I think it's necessary to put us into a bigger context, because I have often gotten the question, well, look, you've been doing this search for 60 years now and you haven't found anything, so that must mean that there's nothing out there to find. And the reason people can ask that kind of a question is because they really don't appreciate how large the universe is and how old it is. So space and time are concepts that our human references don't really deal well with. So let's start talking about where we are. And of course, we're here, right? For most of us, that means that we're locked down in our homes and working remotely, right? For me, it's in this house here in the Berkeley Hills, in the San Francisco Bay Area. And if we are at the altitude of low Earth orbiting satellites, we'd see us here on the west coast of the United States. And since 1968, when Bill Anders took this Earthrise picture as he came around the limb of the moon, we've been able to visualize ourselves here on a planet floating in space, right? And this has become really, this image became an icon for the environmental movement as we began to appreciate what really we mean by being here. And a couple of summers ago, I hope you got the memo, because the Cassini spacecraft turned around as it was orbiting Saturn and took a selfie of all of us here. There's actually a little dot at the end of that arrow, and that's all of us, right? And long before that, as the Voyager spacecraft was passing Neptune, it turned around and looked back and captured this pale blue dot in a ray of sunlight and dust. And that's us, right? And we now understand that our solar system, right, is one of maybe a few 100 billion other star systems in the Milky Way galaxy. And until now, I've been showing you pictures, actual pictures. Well, this is not a picture of the Milky Way, because we have no way of getting outside of the galaxy to make that picture. But we can, in fact, make a radio image of the galaxy from inside by looking at the emissions from methanol and carbon monoxide with radio telescopes. And that job was completed this spring with something like 5,000 hours of telescope time to make this radio map of the galaxy. And you can see that it's pretty close to M101. So this is where we are in the galaxy, and we're not anywhere near the center. We're out in the boondocks. And when we look at the Hubble Deep Field, we're reminded that our galaxy is one of, again, hundreds of billions of galaxies in the observable universe. And as you look here, you see that some of the galaxies are smaller and fainter, and that's because they're farther away. And as we look farther out in space, we're also looking farther back in time because of the finite speed of light. And so we have to think about, when are we, right? Where is our now? Well, now is some 13.8 billion years of the evolution and expansion of the universe. And we humans are actually able to trace our lineage fairly far back in that evolutionary history, right? So we trace our lineage not just back through the centuries of our families, and not just back through the millennia of our architecture and our art and our many experiments with different types of government. We trace our lineage not just back to the billions of years since we split off from the great apes, and not just back to the 2.4 billion years that our atmosphere has been perfused with oxygen thanks to the labors of cyanobacteria, we trace back not just to the formation of our sun and the solar system about 4.5 billion years ago, but we go back millions of years before that to a giant molecular cloud that was actually polluted by the debris from supernovae and the winds of Wolf-Rayet stars, and actually the collisions of neutron stars with other neutron stars to produce nuclides. So we go all the way back there because everything heavier than hydrogen and helium, all the stuff that makes you, was in fact cooked up in the interior of massive stars that, as I say, polluted the this large molecular cloud with debris such as this modern supernovae, and that were then cycled into a process of star formation and planetary formation, just as this material, this modern supernovae remnant, may in fact be cycled into another generation. So we humans are intimately connected with these long ago events and far away places. And so over the past, say, 400 years, we finally come to understand that it really takes a cosmos to make a human. And what we'd like to know is whether the cosmos has done this multiple times, whether there are any other creatures out there with whom we might be able to have a conversation. So there's a field, relatively new field, only a couple of decades old, called astrobiology. And astrobiology is interested in understanding the origins and evolution and distribution of life beyond Earth and on Earth. And there are two subfields that fit under this astrobiology umbrella. One is a search for biosignatures, the other a search for technosignatures. So when we're trying to discover life beyond Earth, we can go looking at various bodies in our solar system, planets and moons and asteroids, to see if we can discover any in situ biomarkers. And then we can go looking for artifacts that might be somewhere in our solar system. And we can take a look at exoplanets and try and do a chemical assay of their atmospheres by looking for biosignatures. So the thing about our atmosphere is that it is very far out of chemical equilibrium. And for example, the coexistence of molecular oxygen and methane, two gases that are very reactive, put them together and you get water and carbon dioxide. And that's happening in the atmosphere all the time. But because of biology on the surface of our planet, photosynthesis and bovine flatulence, we have oxygen and methane in detectable amounts in our atmosphere. And we're wondering whether we can, in fact, do this job for other worlds. Can we make a chemical assay of the atmospheres of different distant worlds and discover whether or not there are any obvious biosignatures? Well, this is a bit more difficult than it sounds because there's a great deal of ambiguity in this kind of research. For example, just recently, we had a claim of the detection of phosphine in the cloud layers of Venus, much closer than the distant exoplanets. So we're still trying to figure out, A, is the line correctly identified? Because it was only a single line detection. So is this the right molecule? Is it really phosphine? And two, how did it get made? Because when we go through extensive studies of chemical networks and reactions, we can't conclude that there's any way to make this large amount of phosphine without perhaps something that we see on Earth, which is we only find phosphine in anaerobic environments, and there it is actually mediated by biology. So is this molecule in the clouds of Venus telling us that there's actually some biology going on there? It's going to take a lot more work to understand actually what's happening. And when you put this same kind of exploration at the distance of exoplanets, becomes harder and harder to unambiguously claim that you found evidence of life biology. But perhaps there is a different way of looking for life that is less ambiguous, and that's to look for the mathematicians rather than the microbes. So perhaps we can remotely sense the work product of some technological civilizations. So that's what we mean by technosignatures. And perhaps we will be able, by building specific instrumentation, to look for these technosignatures, be successful, or just serendipitously, as we continue to build larger and larger instruments to explore the cosmos, we may serendipitously stumble over something that is unambiguously a technosignature. So that's what we're working on now, and trying to understand what kind of technosignatures we can build specific instrumentation for, or what we might be able to observe. And here's a term, commensally, which means at the same time as another observer at one of these new large telescopes. So basically, there are two different kinds of signals that we might be able to detect. Signals that are almost natural and signals that are obviously engineered. So almost natural, what is that like? Well, here's a pulsar. And we've found pulsars that, because of star quakes, change their periods. So to here. But we've never found a pulsar that went from one period back to a second, and then back to the first. But our searches for pulsars would find such a system if it exists, and if it had been engineered. All right, here's another type of almost natural signal. These exoplanets that we've been finding them as a result of transits. We've been looking at the shadow of a planet as it passes in front of its star and dims the starlight. And, the IAU has told us that planets have to be spherical, so that shadow is going to be round. But what if it were some gigantic engineered structure that was decidedly unspherical? There's enough information in the higher moments of the light curves as we stare at those stars, at ingress when a transit begins, and at egress, that we could in fact detect transits by non-spherical bodies that might be engineered. And lastly, there are things called Cepheid variables, right? Stars that puff up, get much brighter, then collapse again with very, very regular periods. This is in fact one of the key ways that we can measure distances as far as the Virgo cluster. Now, suppose you were in advanced technology and you could orbit something around one of these Cepheids. And as the star was quiescent and sitting there thinking about getting ready to expand, you could zap it with energy, a neutrino beam or some other form of energy, and cause it to expand prematurely. That is, it would have a short period. So its natural period would be the long period, and then it would be possible to make a short period. And in fact, depending on your timing, you could encode information in that sort of Cepheid Morse code, short and long, all right? And you could see that all the way across the galaxy. Now, things that are more obviously engineered might be frequency compression in the radio, a single tone on the radio dial. Nature can't do that. Nature spreads its energy across multiple frequencies? How about a nanosecond pulse, right? Repeating perhaps periodically or at some other time frame, but with so much energy in just a nanosecond. Again, nature can't do that. And finally, how about a monochromatic laser beam, such as one that might be used to accelerate a sail to go across planetary or interstellar distances? Those would obviously be engineered. And the difference between these is that for the almost natural signals, you just do astronomy. You do astronomy on steroids if you can. You look in every possible way at every type of object in the cosmos. And you keep an open mind so that anomalies that are found might be reconsidered in terms of someone else's technology. But for these, obviously engineered signals, nobody's building telescopes to go looking for this because nature doesn't do that. But we, in fact, who are interested in looking for extraterrestrial technologies, in fact, do consider and build dedicated telescopes to look for these kinds of things. So finally, in terms of looking for life beyond Earth, we need to remember that in fact, in the future, we may export it. We're actually talking about going back to the moon, onto Mars, visiting and exploring asteroids with humans as well as the robotic probes that we've already sent. And so we may be responsible for life beyond Earth in the future. Now, I really enjoy the opportunity to talk to various groups about these topics because I think that it has the effect of holding up a mirror to everybody on this planet and saying, see, all of you, look at that mirror. You're all the same when compared to someone else, something else that evolved and co-evolved on a planet far from our own solar system. So it has the potential for trivializing the differences among humans that we find so difficult today, right? And I think that's a very important thing because there are many, many challenges that we are facing in the near future as humans on this planet. Water security, food security, climate change, all of these challenges which do not respect national boundaries. And they're going to have to be solved globally. And so if there's something that we can do, like thinking about SETI, talking about SETI, that helps to make us more comfortable with the idea that we are all the same on this one planet, I think that is incredibly important to our long future. And so I'll leave you with some final words from Caleb Scharf, who's the chairman of the astrobiology department in Columbia University. And Caleb reminds us that on a finite world, a cosmic perspective isn't a luxury, it's a necessity. And so I will keep talking about SETI any way I can, as long as I can, because I really think that as scientists, one of the things that we can do is to try and help those that don't get to study the cosmos and don't yet understand the immensity of time and space that is the context for us, and have them remember that they are Earthlings first and foremost. So I usually give a homework assignment and I tell people, when you get back to your devices and every place that there's a profile about yourself, the first thing you should put in that profile is that you're an Earthling, and then start acting like it. And I think we could have a better long future. Thank you.
Hey, Jill. So we have a lot of questions for you in the Q&A, as one might expect. I'm going to start out by just asking you right off the bat. Well, first, I should say thank you for a terrific talk. We really appreciate it. But also, I think there are a number of questions that are just basically about like sort of what's next in technology that could help the search. We had one specific question about a spiral phased antenna array, I think they said. So I was just curious, what's some new tech that you think is going to be exciting in this?
Okay, so there are a couple of things. There are new telescopes coming online, both ground-based and space-based, and they will be used to study exoplanets. We need to figure out how to observe commensally with this next generation of 40-meter telescopes. And the thing that we haven't had much luck at, although we've known that we should do it for decades, we haven't yet had much luck at finding transient events, right? So the way you want to look for a transient is to look at all the sky all the time. And of course, at all frequencies, right? And so we're beginning to be able to tackle that at first in the optical and then later in the radio. And that spiral array, I think that was being alluded to, is the square kilometer array, which we've been talking about for decades, and it's the prototypes have been built for it, and it will be an array of a large number of small dishes, and it will be built in the higher frequency portions of it will be built in South Africa, and the low frequency portions in Western Australia. And we're prototyping these already, and it will cover, it will be built in the Karoo Desert of South Africa, and in fact will cover a number of, spiraling out from the center core, will cover a number of different African countries. And that will be considerably more sensitive than our largest radio telescopes today. So we are intrigued to be doing SETI with that new instrument, as well as the new ground-based 40-meter class telescopes and some home-built instrumentation that is making the first attempt at all sky all the time in the optical. One system called PanoSETI that's being developed at University of California, San Diego. A geodesic dome where the facets of the dome are filled with lenses, and those lenses focus a large portion of the sky onto very small, very fast and sensitive detectors. And of course you have to build two of these, because if you're looking for transients, you need to build up your confidence so that an event, you can be sure, isn't just an instrumental effect if it's detected simultaneously at these two different sites. And lastly, a more modest project that really can look at covering all the sky all the time. And that's a project called Laser SETI, and it's using astronomical grade cameras and gratings to look at all the sky above the horizon at various sites. And you then have pairs of sites and multiple sites in all, probably 15, 16 sites around the globe. And then you really can be looking at all the sky all the time for these transient things. And it's just a huge amount of data that we're talking about. And humans aren't going to look through that, but in fact, neural networks may. So that's the other new technology that offers us a lot of opportunity. Until now, when we've been searching for signals, we've had to tell the computer, look at the data and look for this particular pattern. Narrowband radio signals, very short optical pulses. But now, instead of having to tell the computer what to look for, trained neural networks can look at the data and simply tell us whether there's any data that contains information content of any type. And therefore, it opens up many new types of modulation to our searches. So excited. New telescopes, new neural networks.
So super boring point of order. If you could stop your screen share, then we'll expand out our heads, our faces. But also, yeah, while you're doing that, just, it's such an important mission. It's, answering a fundamental question to being human. So, without getting too technical, how is SETI supported? I know it started as a NASA program, but it's not anymore. Like, how's it supported? Is it on stable ground? How does that all work?
Well, SETI is all supported through philanthropic private donations at this point. And at the SETI Institute, we have large dreams of establishing an endowment, because that's the only kind of fiscal vehicle that we can think of that might provide continuous funding for something that may in fact be a multi-generational project. So we are trying to raise that endowment. We certainly are just at the beginning, and we haven't been very successful yet. But there's another source, another philanthropic funding source, Yuri Milner, who has funded Breakthrough Listen for on the order of at least 10 years and more, we hope. So there are two projects and another one at Penn State, where again, an endowment is a desired mechanism for funding, because maybe my granddaughter that succeeds, not our generation.
So can you just maybe speak broadly about what it's like to go into a field that without having any feeling that the work will be finished within your lifetime, this sort of multi-generational field that you're in, what kind of person makes that kind of endeavor? Like, what was it about it that drew you as a young scientist?
Well, for me, it was the fact that this is such an important old question. And I was at the right place at the right time with the right set of skills. So I had engineering background and astronomy, astrophysics. And I was astonished by something called the Cyclops report, which was an engineering design study that was run at Stanford and NASA Ames Research Center in the early 70s. And when I read through that report, I was just hooked by the idea that, actually after all these millennia of asking the priests and the philosophers what we should believe, there were actually some tools that would allow us to try and find out what is and not have to depend on somebody's belief system. And I thought, I couldn't imagine anything more important to do than that. And of course, if you get out of bed in the morning and you say, I'm going to find a signal today, well, you're probably going to go to bed disappointed. But if you get out of bed in the morning and you say, God, technology and computing is getting so much better. How can I do the search better today than I did last week? And that kind of incremental progress, at least for somebody like me, is very satisfying. Thinking about what we can do now versus what we could do when we started, it's staggering. And we can make it better tomorrow.
So a very science and entertainment exchange question here from one of our audience members. In the movie Contact, it sort of ends up being math that is the mode of communication for to speak with the alien race. And somebody mentioned, could music potentially be another one? Are there other modes of communication that you could see potentially allowing us to send a message or have them send a message?
Well, okay, whatever medium you use to carry the information, it has to transmit over interstellar space. So sounds, no, but you can have digital instances of music. In fact, we're doing a project called Earthling, where we're inviting the world to send us songs about what it's like for them where they are, and songs about grief and birth and death and celebration and that kind of thing. And we're creating this Earthling platform that will, first of all, Felipe Santiago Perez, a very well-known composer and musician from Mexico, is going to create a symphony out of those songs. And the platform will allow anybody who wants to take these digital fragments and create their own music. And the reason I bring that up is because we are trying to take that symphony, that Earthling symphony, to the moon and then onto Mars to remind the colonists about home. But there are other kinds of information carriers. You could imagine, first of all, the carrier probably isn't going to be charged because it would get deflected by the magnetic fields in the galaxy. But you could think about neutrinos, you could think about gravitational waves, you could, and so this multimedia kind of astronomy that we're doing now might in fact have some applications to SETI. It's just a whole lot harder, given where we are with our technology, a whole lot harder and more expensive than investigating electromagnetic radiation. And in terms of how you encode the information, music might be possible. The problem, we've always said math, but the problem with that is that I think we're now beginning to understand that the way our mathematics are expressed is in fact shaped by the nature of our human brain. And somewhere else, someone may use mathematics to try and describe the same physics that we're trying to describe. But because their mathematics will also have been shaped by their brains, we might not recognize it as being the same thing. So, yeah, I mean, that's a problem I'd love to have, the decoding, right? I'll sign up for that one. But indeed, it may be pretty difficult.
So we have a few questions that I think boil down to the idea of, like, when you consider the vast distances in this communication channel, what are some of the more interesting scenarios you've thought of over the years, in terms of, like, one example that an audience member gave was, we get a signal, we send a response, but this response takes so long to get there that the alien race goes extinct, or we go extinct before the answer comes back. Like, are there other scenarios you've envisioned or imagined over the years with those kinds of, I mean, the distances are so vast.
Right. So the tyranny of light speed is the problem here. And one of the things that we've envisioned is that it might be more like the conversations we have today with the ancient Greeks and Romans, right? We can read things that they wrote and that have survived over the centuries, but we can't ask them anything in return. So an interstellar communication might be more like that one-way transmission forward of information, and we'll have to learn from what they choose to tell us rather than what questions we'd like to have answered.
So are there other films besides Contact that you think have interesting or grounded portrayals of first contact or alien life?
Yeah, I actually liked The Arrival. And one of the reasons I liked that was the concept that if you're going to write in circles, you have to know the future. I thought that was a very intriguing idea.
We had a couple of questions surrounding the moon. So I'm going to throw out two questions that are a little bit off, but on the theme of the moon. One is, are there any plans to put some sort of a sensor on the other side of the moon? Would that be helpful to the search? And then the other question involving the moon is, how important do you think the moon is as an indicator of, you know, life on this planet, intelligent life on this planet? Is that something that we'd be looking for in another planet, that it would have a moon?
Okay, so the lunar far side is an extremely unique environment. It's the only place that never has the Earth in its sky, right? And so one of the biggest challenges that we have with looking for radio signals or even optical signals, astronomy, is pollution, right? Radio frequency interference and light pollution. So if you can use the moon as a shield to get rid of all of our own terrestrial transmissions, then you have a much quieter environment. Now, it's going to be difficult to build a large radio telescope on the lunar far side, but not impossible. And there have been some design studies of what that might look like. And the problem is that although the ITU back in the 60s defined the shielded zone of the moon in which there should be no transmitters, they did this for astronomers of the future. We're kind of messing up our own nest, because there are plans to build things like the gateway structure at the Lagrange point at the far side of the moon, which will in fact be very radio loud. And so as we go forward with that and think about the communications, I think that one thing that we could do, because you're not going to stop NASA or ESA or any spacefaring nation from doing that sort of thing, I think what we could ask for, and presumably have a reasonable chance of getting, is that any communication scheme be developed on 2 different frequency ranges, so that at any one time you can turn one off and observe there, and then turn the other off and observe over there, so that you wouldn't have continuous access to all the spectrum, but you would have access to all the spectrum part of the time.
So I think we have time for one more question. We've got about 2 minutes left. We had a question about Fermis Paradox, which can basically be summed up to, if there are aliens out there, if there are other cultures out there, where are they? Why haven't we found them yet? Is my base understanding. But how do you respond to that thought?
My response is that there isn't any paradox. And that's because if you look at just electromagnetic radiation signals searching, and you look at all the different parameters you need to search through, frequencies, position on the sky, polarization, modulation, signal strength, etc., 9 dimensions. And if you make some reasonable guess of the size of each of those dimensions, and then you create a volume that represents this 9-dimensional space, right? I'm terrible, I can't visualize that. So what I've said is that let's set the volume of that search space equal to the volume of all the Earth's oceans. And then how much have we searched? How surprised should we be that we haven't yet found a signal? And the answer is, we shouldn't be surprised at all, because our searching to date represents 1 glass of water out of the oceans. So actually that was 10 years ago when SETI turned 50. Now at 60, it's more like a hot tub's worth of the ocean. And the thing is, there's a huge amount left to be done. And our tools were getting better exponentially. But we really shouldn't be saying they're not here or they're not sending us signals on the basis of what we've been able to do so far. We just haven't looked enough to make a paradox.
Well, Jill, we quite literally have nearly 100 more questions that are in queue. And some of our audience will be joining us over in the VIP link to ask you their questions in person, or in virtual person, as it were. Thank you so much for taking this time with us today. If we didn't get to your question, I am very sorry. It was just a lot of interest in this topic, as one might expect. And with that, over to you, Anne.
Well, again, thank you very much, Jill. We feel like we beat our audience to the punch by asking for a talk on astronomy, and so we very much appreciate you delivering what they wanted, because there, as Rick said, lots of questions, lots of people here in the virtual audience, and this is just such a I think there's a lot of interest in sort of like, stop, let's not look at Earth anymore. This is just not a good time to be looking at Earth. Let's look up and think about something else. But I do really like your point that we just haven't looked enough. So Dave Gallo, who is a marine explorer, who has actually he was the co-expedition leader for the expedition that found Titanic, and he was also the expedition leader for finding the downed Air France flight, has always said, you have to give me a haystack, and then maybe I can find your needle, but you still have to give me a haystack. If you ask me to look everywhere in the ocean, of every ocean, like, that's just really hard. And so I guess what you're saying is, like, this haystack is just unfathomably large. And so we're just everywhere looking, and that's not so easy. If somebody told you what haystack to look in, perhaps it would be easier, but nobody's telling you what haystack.
Well, the astrobiologists are starting to think about habitable, what exoplanets might be habitable, and those would be a good place to look.
Yep. Well, this has been really special, and we thank you very much. So we know that there are others who do have more time with you, and that's a good thing. And we hope that you, as our audience, will give us more time when we come back. Not next week, because that's the Thanksgiving break. So please do stay safe. I know the public health officials are very concerned about next week, because it's going to be hard to not gather. But I know that's what they're encouraging us to do, to refrain and stay safe. So whatever you do, however you celebrate your Thanksgiving holiday, please do it safely, because we'd like to see you in a couple of weeks back here in our virtual audience. So thank you for being here.
Yeah, see you in December, everybody. And please do fill out that survey. We are going to do our events in 2021 based on responses. So yes. Thank you very much. We'll see you in December.
Exactly. Bye.